twos and threes. You guys are going to watch the video and fill out your notes as you go along. Feel free to pause it when you need to. So if you need to copy anything down, if I'm going too quickly, just take a quick pause and make sure you get everything. Today we're going to talk about systems of equations, and I'm actually going to be teaching you guys 3 different methods on how to solve systems of equations. You are going to pick which one you like and stick to it, but I'm going to show you 3 different ways. First off, a system of equations is when you have 2 or more equations with the same variable. So instead of us graphing 1 equation, we're going to be graphing 2. The solution to a system, we can find it graphically, so we're going to graph some of them down here, and then we can also find it algebraically. Graphically, it's the point where the 2 lines intersect or where they cross. Algebraically, it's the point that makes both equations true. And remember when we did substitution, we plugged in the x and the y values. That's how we know if it makes the equation true or false. We have 3 different types of solutions. We can have intersecting lines that cross. That results in one solution. It's a point. We can also have parallel lines which do not cross. Remember, parallel lines have the same slope. These lines have no solution because they do not cross. And then we can also have solutions that are the same lines. If we have, if we have equations that make the same lines, those are called infinitely many solutions. And it's like the infinity sign. You've probably seen this as a tattoo before. But these are the 3 types of solutions that we have. So depending on the kind of lines we have, that tells us how many solutions we're going to have. We can have 1 solution, no solution, or many solutions. All right, we got 3 steps to solving equations by graphing. That's the first one we're going to talk about, the first method. The first step is to rewrite the equations into slope-intercept form. So if this equation is given to you in standard form, you want to make sure it looks like y equals mx plus b. So rewrite it into slope-intercept form. Step 2 is to graph the actual line. So on delta especially, we're going to practice graphing the actual line on the graph. Make sure you copy down the graph on your paper. And step 3 is to identify the solution. So remember, we can have 1 solution, we can have no solution, or many solutions. On this first example for graphing, our equation is y equals 1x minus 8. So our y-intercept is at negative 8. Our slope is 1. We go up 1 over 1. And that's how we graph that first line. The second one is y equals negative 2x plus 1. So you start at your y-intercept of 1. Since your slope is negative 2, that means you're going to go down 2 and over 1. Down 2 over 1. And that's where what the second line looks like. The solution, remember, we're looking for the point where those lines cross or intersect. And we know that these lines have 1 solution right here. That point is at 3, negative 5. So that would be our answer. That's our solution. If we plug these values in for x and y into either one of these equations, it would make the equation true. For example, if we plug in the x here, we got 3 minus 8. If you do 3 minus 8, you get our y value of negative 5. So that makes the equation true. We can also take a look at number 2. If we have the equation y equals 1/2 x plus 9, the y-intercept is 9, so we start at our y-intercept of 9. Our slope is 1/2, so we go up 1 over 2, and that's what that line looks like. For this one, if we start at the y-intercept of 6, our slope is negative 1. So instead of going up, we go down 1 over 1, down 1 over 1, and that's what the other line looks like. The solution is a point where those lines cross, so our solution on this one will be at negative 2, 8. And remember, we can plug those numbers into either one of these equations, and it should come out to be true. The next way that I'm going to teach you, and remember, if you need to pause and take a time to write all this down, go ahead. I'm trying to make the video as short as possible. The next method that you're going to learn is substitution method. Remember, it's just an option. I do want you to practice it, and we are going to do some more examples, especially in our delta with substitution. But if you prefer the graphing method I just went over, you can always go back and do that one. Substitution is another method of solving systems of equations by substituting equations within one another. Our first step is to solve one of the equations for x or y. Sometimes it's given to you. As you can see on this example, it's already y equals, so sometimes it's given to you. But if not, you can solve it and make it x or y equals. Step 2 is to substitute this expression into the other equation and solve for the variable. And you'll see what that means when we get to the example. Step 3, substitute your answer into the revised equation from step 1 and solve for the other variable. It sounds like a lot of steps, but honestly, substitution can be very easy. On this first example, let's go back. Wait a minute. On this first example, as you can see, both of these are already y equals. So we already have step 1 done. One of our equations is already y equals. So since both of these are y equals, if this one is y and this one is y, we can set them equal to each other. So 4x minus 1 is equal to 2x minus 5. Those are y equals y. If you solve for x on this one, you're going to move your letters to the left, so you subtract the 2x over here. 4 minus 2 gives you 2x. Everything else comes down. Then we're going to move this negative 1 to the other side. When we move it, it becomes a plus 1. Negative 5 plus 1 is negative 4. And then our last step to get the x by itself is divide, so x is equal to negative 2. Now, if we know what the x is, then obviously we can use that and substitute it in here and figure out what our y is. So if we substitute the x in, we get 2 times negative 2 minus 5. 2 times negative 2 is negative 4, and negative 4 minus 5 is negative 9. So now we can easily see the x value of our solution is negative 2, and the y value of our solution is negative 9. For the second example, this is an example where one of our equations is y equals, and the other equation is not. So this one is in standard form, ax plus by equals c. Now, the good thing about substitution is, because I already know what y is, I can plug it in for y right here. So that's what we're doing on this problem. So we end up with 2x plus 3, and instead of y, now we know that y is 6x. We're going to plug that in for the y value. Equals negative 20. 3 times, and notice, real quick, sorry, use parentheses when you're substituting. So don't just put 3 and then put the 6x right next to it. That's going to look like 36, right? So make sure you use parentheses when you substitute so you can remember, 1, if there's a number outside, you're going to multiply. And just so you know that this is the value you're substituting in for the y. You're taking the y completely out and putting in the 6x. That's what it told us. So 2 times 2x plus 3 times 6 is 18 equals negative 20. Remember, after distribute, we can combine our like terms. So 2x and 18 gives us 20. And to get the x all by itself, we're going to divide both sides by 20, and x is equal to negative 1. Now that we know what our x is, we can plug that into our equation over here and figure out what our y value is. And 6 times negative 1 is just negative 6. So far, substitution can be quick. It can be easy. If you wanted to use graphing for this, you could, but you would have to make sure you substitute this equation for y. Not substitute, solve it for y. So if you wanted to graph this one, you got to make sure you move the x over and divide like we normally do, but you can still go back to graphing if that's what you want. You are going to practice substitution, okay? All right, so elimination. The third method, the last method, is elimination. Elimination is another way for solving systems of equations by adding or subtracting to eliminate a variable. What does eliminate mean? Think about it. We're trying to get rid of something. So here are our steps to do elimination. First, we're going to make sure the equations are lined up. X's with X's, Y's with Y's, numbers with numbers. You know how it goes. Step 2, we're going to add or subtract the equations to eliminate the variable with common coefficients. I know we haven't really talked about it much, but coefficient is the number in front of the variable, and I'll talk about it when we get to our examples. Step 3, solve for the remaining variable. Step 4, substitute your answer into either of the original equations and solve for the other variable. So I want you to notice this step right here is just exactly what we did up here on step 3. So we're going to take the number that we end up with and substitute it back into one of these equations. Doesn't matter which one, but make sure we substitute back into the original equation. And I want you to also notice, to eliminate, we can add or subtract. Doesn't have to be add or, doesn't have to just be add. We can add or subtract. So when we take a look at the examples on this one, we have y equals 3x plus 4, and we also have y equals x minus 2. Now, of course, both of these are y equals. Honestly, it might be easy to just graph these in Desmos since we could type these in. But let's say I wanted you to practice elimination. Here's what I want you to think about. Coefficients are the numbers in front of the variable. So in front of this y right here, there's a 1, and in front of this y right here, there's a 1, right? So if we have variables that have the same coefficients, right, common coefficients, we can add or subtract these equations to eliminate it. Here's what I mean. Let me see if it's going to let me work. So if we have 1y right here, that didn't work. Let me try it again. Let's get some color. There we go. So let's get that other one. 1y right here, and then we have another 1 right here. Think about it. If we do 1 minus 1, we end up with 0. It's eliminated like we want it to be. That's the whole process in elimination. You want to eliminate one of the variables, and that happens when they have common coefficients. So both of these have a coefficient of 1. I know that if I do 1 minus 1, it goes away, and that's what you want. But then we got to keep subtracting the whole equation. We can't just do the y's. So 3x minus 1x gives us 2x, and then the 4 minus negative 2. Be careful right here, you guys, if you need to use Desmos. 4 minus negative 2. Remember, when you have two minus signs next to each other, I ain't got my iPad. This is difficult. When I got two negative signs next to each other, those two negative signs become a, that's ugly, plus, right? So right here, when we have 4 minus -2, that's a positive 6. All right, so now remember, we're still trying to get this x all by itself. So we're going to move this positive 6 to the other side. When we move it, it becomes a negative. And to get the x by itself, we divide both sides by 2, and we end up with x equals 3. And just like before, if we know what x is, we can plug this back in to figure out what y is. So if I plug it back in, we get y equals, and instead of x, we know that x is -3 minus 2, and -3 minus 2 is -5. If we wanted to, we can plug both of these numbers back into either one of these equations, and we should end up with something that is a true statement. For example, if we plug the x back into this equation, we get 3 times -3, which is -9, and -9 plus 4 would end up with the y value of -5. So that would be true if we plug that back into our statement. That's a check mark. All right, so let's try another elimination. Here's how you know you can eliminate. When you have these two variables right here that have the same common coefficient, so both of these x's have a 1 in front of them, right? That's the same coefficient. It's a common coefficient. So how can we get rid of it? We subtract. 1 minus 1 gives us 0, so it goes away. 4 minus -1. Be careful, there is a 1 right there. 4 minus -1 is 5. Remember, 2 minus signs make a positive. We're not multiplying, but 4 minus -1 is 5. 13 minus 3 is 10. And to get the y all by itself, we divide both sides by 5. We end up with y equals 2. If we plug that back in to this equation here, it's x minus 2 equals 3. We move this -2 to the other side. It becomes a positive, so 3 plus 2, that gives you 5. So elimination can be very easy. If you can just find those common coefficients and add or subtract the equations to eliminate the variable, then you can easily find your x or your y and use that to plug it back in and find your other variable. Okay? Now, it's not always easy, I'll be honest. Sometimes there are not common coefficients. If we don't have common coefficients, we might have to multiply one or both of the equations by the same number to create matching or opposite coefficients. It's not ideal to do this, you guys, I'll be honest. If you have two equations that aren't lining up correctly or don't have common coefficients, it might be easy to just solve this one for y, solve this one for y, and graph it like we can do, you know? We know how to move the x to the other side and divide, and then type it into Desmos and click where they cross, right? We can do that on these questions. But if you like the process of elimination, or if the problem just asks you to do elimination, maybe I just want you to try it. Here's a way you can get around it. So on this problem, I want you to notice how before we had two variables that had the common coefficient. So both of these had the coefficient of 1. The x is here. Both of those have a coefficient of 1. On this question, this x has a coefficient of 1. This one has a 2. This y has a coefficient of 3. This one is -7. So none of our coefficients are matching, right? But what we can do is we can make this 1 into a 2 if we multiply this whole equation by 2. So if we do 2 times x, that gives us 2x. If we do 2 times 3y, that gives us 6y. And if we do 2 times 6, that's 12. So if we multiply that whole top equation by 2, this is our new equation right here. Same thing, just every number is multiplied by 2. And if we bring over the equation that we already had, I want you to notice now we have common coefficients. This x has a 2 as a coefficient, and so does this one. So now we can subtract these equations to eliminate. 2 minus 2 is 0. 0x, it goes away, right? 6 minus -7 is 13, and 12 minus -1 is 13. Be careful. Divide both sides by 13, you end up with y equals 1. And as we did before, anytime we know what one of the letters is, we can plug that back into either equation and figure out what the next one is. So if we plug this one back in, we get x plus 3 times 1 equals 6. 3 times 1 is 3. And then we move this to the other side. That becomes a -3. 6 minus 3 is 3. So be careful. Make sure when you write your solution, your x goes first, and then your y. Your solution is 3, 1. All right, and for this last one, if we have 9x plus 3y equals 12, and then we have 2x plus y equals 5, let's say we just had to practice some elimination on this one, right? What we can think about is, okay, how can I make any of these numbers common? Well, this y has a 1 in front, so it'll be easy to change it to a 3. All we have to do is do 1 times 3, and that gives us 3. So we're going to take this whole bottom equation here, and we're going to multiply the whole equation by 3. 3 times 2 gives us 6. 3 times 1 gives us 3, and 3 times 5 is 15. Now that we have common coefficients here, these are both 3's, we can subtract these equations in order to eliminate the y. So 9 minus 6 gives us a 3. 3 minus 3 is 0, so it goes away, it eliminates. And 12 minus 15 is negative 3. We divide both sides by 3 to get x equals negative 1. Now that we know what our x is, we plug it back in and we can figure out what our y value is. And for time's sake, I'm going to just keep going just a little bit. But like we said before, you can plug this in, check it on either solution, and it should come out to be a true statement.